Okay, so after discussing all the idea and concept about the transformation of graph, all right, so now we are going into the next part for the function. Um, we are going to discuss the algebraic operation of the function. Right, basically this is a very simple part, okay, very easy. It's super easy, nothing special. All right, so we will just go through it very fast. Okay, so we can actually combine two or more functions in a number of ways. So, right, so as an example, you can actually add the functions together. So we take example as function fx equals to x squared, function gx equals to 2x plus 6. So this one, if you do fx plus gx, what do you get? You are having x squared plus 2x plus 6. So this is fx plus gx. If let's say you are taking function g plus function f, then what do you have is 2x plus 6 plus x squared. So if you compare these two answers, generally you'll find that they're actually the same. Okay, so there's one important result that you need to know here. When you are having fx plus gx, it will be equals to gx plus fx. Okay, right. So how about subtraction? Okay, so for subtraction, if you're having fx minus gx, then what you have is you're having x squared minus 2x plus 6. Alright, so when you're having x squared minus 2x plus 6, if you try to simplify it, you have x squared minus 2x minus 6. Alright, and when you're having gx minus fx, then you're having 2x plus 6 minus x squared. Alright, so if you compare these two answers, generally you'll find that they are not the same answer. Therefore, you should know that f minus g is not equal to g minus f. Okay, so it's a very simple concept. Like when you're having 2 minus 1, the answer is not equal to 1 minus 2. But when you're having 2 plus 1, the answer is equal to 1 plus 2. All right, so the idea is very similar, or is similar, is the same as what we have for the number system. Right, okay, so next, let's continue with the multiplication. All right, so when you want to multiply fx with gx, then what do you have is you should have x squared multiply with 2x plus 6, and therefore you should have 2x power 3 plus 6x squared. So the same thing happens if let's say you take gx multiply with fx, and if you expand everything, generally you will see that answer is also the same. Alright, so f times g equals to g times f. Alright, then after that, we continue to the division. So for division, if you are having f divided by g, then you will have x squared divided by 2x plus 6. And then gx divided by fx, you are having x squared, 2x plus 6 divided by x squared. So again, if you compare these two answers, are they the same or not? They are not the same. Alright, so from here you will see that for addition and also multiplication, right? If the sequence of the addition and multiplication is different, generally the answer will be still the same, will not be affected. Okay, but if let's say when you're having subtraction and division, right, the answer will be different. If let's say you are using the sequence differently, or maybe you take f divided by g or g divided by f, or maybe f minus g and g minus f, the answer will not be the same. Okay, right. So this is something very simple, just to let you know that addition and multiplication will have the same answer, okay, if you change the sequence of this operation. All right, but it is not the same happen for the subtraction and also division. Okay, so generally this part is not really important, right? But it is just something simple to let you know about it. Okay, then now let us proceed to the next part, which is more important. Okay, so for the next part, we are going to discuss the composition of functions, or we will call it as composite function. Okay, so you need to know how to find the composition of two given functions. All right, and then again, I believe that most of you already learned this before, but later I will discuss something new that will be introduced in A-level syllabus, okay, for this part. So I will go with some basic idea first. Then after that, I will discuss the new concept that being introduced here. All right. Okay, so let's start with the basic idea about the composite function. So if let's say I'm having two functions f and g, and the composite function we denote it by a white circle, f composite g. Okay, and when you write it in the equation, it will become f composite gx, which is equals to, you are putting the gx inside the f. Okay, so what does this mean? Okay, as an example, if say you're having a function, okay, let's say fx equals to 3x squared plus 2. Let's say that, and if let's say gx, they give you a triangle x, something like that. Okay, then if let's say they want you to put f gx, then what will happen is you need to put in the triangle x into your original x, and then you square, then plus 2, something like this. Okay, so I believe that most of you learned it before actually. Okay, so this is why I call it composite function. That means you are putting one function into another function. When you want to put in one function into another function, right? So you are substituting the x in that function, okay, with what you want to substitute. Alright, so we call it as composite function. And then for composite function, you will see that the symbol is a white circle. Okay, and then if, let's say, in the exam, when you see this symbol, let's say f. Okay, so what does it mean? In f dot g means that fx multiply with gx. If f a white circle g, so that means it is f composite g. Okay, so please take note on the difference between the white circle and also the black dot. Right. Okay, then now, for any composite function, it can be represented in an arrow diagram. Okay, so I think you need to draw the arrow diagram here. All right, so generally, when you are having f composite g, what does it mean? Okay, so I will draw this. Okay, so there are 3 circle here, 3 set of values here or elements. Okay, no matter how. All right. So now, first, when you're having, sorry, maybe I need to write it clearly here. If I want to have f composite g, then x. All right, so the graph will look something like this. So first, it is actually you need to send the x by using the function g first. So that means if let's say all these are the x, okay. So when you want to send all the x through g. Okay, all right. So maybe I will label this as g. This is the function g, right here. Cannot function g. Okay, and then if let's say you look at this one, this is the starting value. Okay, this is the ending value, right? So according to what we learned before, this is actually the domain. This is actually the range, correct or not? So if I label it, I will label this as domain of G, and this set of data or this set of value will be the range of G. Agree? Okay, then next, after I send the x through the function G already, then followed by the other function f. So that means from here, I'm going to send my value again through another function, and we call it as function f. All right, so this one I label it as f. Okay, so if you look at this blue color function for function f, right? This set now is actually the domain of f because this is where the function f starts. So this is domain of f, and this is the range of f. Right now. Therefore, you're having the domain of f and also the range of f. Oh, sorry, range of f, not g. Okay, so for you, right, maybe you will think that, okay, like this is just a normal type of arrow diagram for composite function. But in this arrow diagram, actually, they have a very important information here, which is this one. You will see that the range of G, okay, and the domain of F are from the same set of value. Okay, so usually when we are having the composite function, you need to know also from here there's a small conclusion or maybe a small result that you need to know, okay, which is the range of G is equals to the domain of F, okay, when you are having a composite function of F composite G. Okay, so how I know this result? It is because of the arrow diagram here. All right, so you can see that this set of data or this set of value, right, is actually the same. Okay, and then it belongs to the range of G. It also belongs to the domain of F. So the short result, or maybe a short concept, a simple concept that you need to know is the range of G is equals to the domain of F if you are having the composite function this one. Okay, so when you're having a composite function like this, that means G come first, followed by F. Okay, so G come first, followed by F. Okay, so this is something new that we want to introduce in A-level syllabus, and these few years now, right, in the maybe near 8 to 10 years, okay, and 8 years to now, all right, they started to ask more questions about this concept. Okay, so no matter how, I'll discuss more questions about this concept later. All right, okay, so please take note on this part. To me, this is very important. Okay, so we'll discuss it later. All right, so if you continue further, you will see that in our notes, I write something like this. The domain of F composite G is always a subset of the domain of G. So no matter how, right, this set generally they start from domain of G. So that means the domain of F composite G should be also equals to the domain of G. Subset means either the set or smaller, right? Okay, so usually we'll assume it as small as equal. And then F composite G is defined if RG is a subset of DF. So again, I will usually tell students, don't get confused by the word subset. They are not going to test you until so detailed. Okay, so usually we'll assume that the range of G is equal to the domain of F. Alright, okay, so again, this is something new to us. So we'll discuss this, some question about all this in the next video maybe, or maybe later. Alright, at the end of the video. It depends on how long the video is. Okay, so let's continue with example 8 first. Let's discuss some basic composite function idea first, the question first. After that, only we discuss the harder one, the new concept. Okay. All right. So let's have a look for example 8. Okay. So for example 8, they give you this one. Okay, and A and B are constant, and there should be numbers, but they actually didn't let you know what is the number here. And it is given that F2 equals to 1 and also F5 equals to 7. Okay, first they want you to find the values of A and also B. Okay, so this one is a basic idea about function. F2 equals to 1. That means what? That means you substitute the x become 2. So you put this one as 2. Alright, so if substitute x become 2, so you should have 2a plus b, correct, which is equals to 1. So this is the first equation. Alright, then the formation given here is f5 equals to 7. Alright, so that means you substitute the x by using the 5, and therefore you're having 5a plus b equals to 7. So this is the second equation. So I think very easily you should know already how are you going to get the value for A and B. You have to solve simultaneous equation. Alright, so I won't solve it for you. Please try it on your own. The A should be a 2, B should be negative 3. Okay, so please make sure that you solve it yourself and try to get this answer. Okay, so this is what we have for part 1. Very, very simple. Then now let's continue to part number 2. So solve the equation of F composite Fx equals to 0. Okay, so F composite Fx equals to 0. Oh, then another thing. Some students will say, does this means F multiply with X? If let's say they are multiplying, they will write it like this. Fx multiply with Fx. Okay, if they write Fx, generally it means what? It means that it is composite function, F composite F. Okay, and then sometimes they will write it like that, F square and the X, some of the book lah. So this one also means composite function. Okay, so if let's say they want you to make this one, the symbol is what? The symbol is bracket fx, the whole thing square. So that means this one means you multiply the fx with fx. If let's say you're having this composite function, then generally it is f square x. Okay, so please take note about the difference between all these. Yeah, right. So now let us start with fx equals to 0. Okay, so first, okay, so f, usually I'll put the bracket here for the fx equals to 0. So now that means now what you need to do is that you have to substitute the fx into the fx. Okay, so substitute the x as ax plus b, or maybe you can do it like this. What is fx here? So fx is ax plus b equals to 0. So that means now you need to substitute ax plus b into the x in the function f. Okay, so if you continue, then you will have a. The x now, you have to substitute it by using ax plus b. Okay, and then the original equation is ax plus b, right? So you're having a, this green color thing is x, then plus b, and it is equals to 0 after you substitute it. Okay, all right. And then because just now you already get the value for a and b, so to make my calculation easier, I will substitute all the value for a and b straight away. Okay, so what's my value for a? It is a 2. My value for b is a -3. So here I'm having a -3. Here I'm having a 2. Then inside the bracket, I'm having 2x minus 3. Okay, so from here you can see very easily. Okay, substitute the multiply the 2 inside. You have 4x minus 6 minus 3, which is equals to 0. And if you continue, then you will get x equals to 9 over 4 easily. Okay, so I believe that all these are very simple to all of you. You can actually try all the example here first, then only maybe you check the answer later. Okay, all right, you can pause the video first if you want. Try all the example, and then only you come back to the video to check your answer. Yeah. All right. So this is what we have for example 8. Okay. Then now let's continue to example 9. Okay. So for example 9, what we have here is you are having the function f. You are having the function g. Okay. So first they want you to find the value of k, which the equation f g x equals to x has 2 equal roots. Okay, so maybe when you look at this one, what is the keyword here? 2 equal roots. So last time we learned 2 equal roots, this phrase in chapter 1, right? Okay, if you want, you can look back to chapter 1 and try to find out where did you see the phrase, the word 2 equal roots. So generally when you're having 2 equal roots, you have to use the equation b squared minus 4ac equals to 0. Okay, but before that, you have to try to find out this one first. Fgx equals to x. So you need to start from this part first. Okay, so I want to get fgx equals to x. Okay, so now what is gx? Gx means 9 divided by 2 minus x. And is equals to x. I want to substitute this whole thing into the function f. So when I substitute it, will become 4. And then I'm having 4x, right? So the x I substitute with 9 over 2 minus x. So my function is 4x minus 2k, and it is equals to x. Okay, so this is the equation that you have. And then because in this equation, you see that you have 2 unknowns here, 1k and also 1x. All right, so you cannot solve and get the answer. Therefore, when you try to how to say when you try to rephrase it, rephrase this equation, you will get one equation like this, which is x squared plus 2k minus 2x plus 36 minus 4k, and it is equals to 0. So you should get this equation here. So I skipped a step already. I leave it for you to continue and complete it. So you should get this equation. So this is a quadratic equation actually. in terms of x, right? Okay, that x squared plus something x plus something equals to 0. Okay, and then this is a quadratic equation, and because of they give you this keyword here, 2 equal roots. So when you are having 2 equal roots, that means what you have to use the result b squared minus 4ac equals to 0 in the from the quadratic equation. So b squared minus 4ac equals to 0. So what is your b? 2k minus 2 squared minus 4ac. Alright, so if you try to continue from here, you should get two value of k, which is k equals to negative 7 and also k equals to 5. That means there should be two values for k. If let's say your k is having this value, then when you try to solve this quadratic, this composite function, you'll get two equal roots. That means the value of x is the same. Similar thing happened for x, k equals to 5. Alright? Okay, so this is what we have for part 1. Okay, then how about if we want to solve number 2? Okay, so what is part number 2 about? So they want you to determine the roots. So again, what is the meaning of roots here? The value of x. Okay, so they want you to find the value of x for this composite function again. Okay, for the values of k found in part 1. Okay, so now first you need to know that when k equals to negative 7, okay, so if let's say when k equals to negative 7, what will happen to this quadratic equation here? So you have x squared minus negative, we are having negative 14 minus 2, which is negative 16, right? So negative 16x, then plus, this one will become 28 plus 36, you should have 64, and it is equals to 0. So you'll get a quadratic equation like this, and you try to factorize it. Now you will get x minus 8, which is equals to 0. And then you'll get one value for x only, which is x equals to 8. That means for this quadratic equation, you are having equal roots. X equals to 8 and x equals to 8, both of them are equal, so they are having equal roots. Okay, all right. So again, you need to consider another case when k equals to 5. Okay, so again, you will get, substitute the k equals to 5 into this equation here. You'll get a quadratic equation. I won't show you what is it. And then if you try to simplify and try to solve the quadratic equation, you should get x equals to negative 4. So this part I leave it for you again to complete it. Okay, so this is how they ask you the question. All right, so this question particularly, they try to combine the composite function with quadratic equation that you learned before. Okay, because you need to apply the idea of equal roots here. So it is actually belongs to chapter number 1. So you can see that all the chapters are related to each other. All right, okay. So next, example 10. So example 10 and 11, right? Generally it is something to recall, help you to recall back. There are some questions that you tried before, and I think that all these are important. Okay, so I will discuss it with you here so that you remember what have you learned before actually in the secondary school. Okay, so let's have a look for example 10. So they give you a function here which is fx equals to 2x plus 3. And they give you a composite function which is f gx equals to 10x minus 9. And they want you to work out the gx. Okay, so to me, right, I will want to use this information first to start my equation. Okay, so f, I'm having f gx equals to 10x minus 9. Okay, so if I look at this f gx here, okay, I want to substitute the x with the x. Therefore, the gx, I also put it into the x here. Okay, but I don't know where's the gx, right? So I just put it like this. I'm having 2 gx plus 3 equals to 10x minus 9. Okay, so you move the 2 over, then you have 10x minus 12. And then if you move the 2 over again, then you're having 5x minus 6. So your gx is actually 5x minus 6. Okay, so I believe that you tried this question before. Maybe already long time you didn't try it, you forget the method. Okay, but this is again another important question that you should know. Alright, okay. Then next one, example 11. Okay, so if you example 11 here, they give you composite function. They give you gx, and they want you to find out g composite f. Okay, so now the problem now is I have gx, I don't have fx. Okay, I don't have fx. So if they want you to find the fx, right, generally you need to find the fx first. Then after that only you can find out the function. Okay, so by looking at this information, okay, and also this one, how can I use this new information to find the fx? Okay, so let us start now. F gx is equals to 4x squared minus 2x plus 1. What is your gx here? So your gx is 2x plus 1, right? So I'm having 2x plus 1 equals to 4x squared minus 2x plus 1. Alright? Can I? Okay, so maybe for now, I will, because my aim is to find out fx lah, or maybe fy. Okay, fx or fy or whatsoever. So if I want to change this one become y, I will let y equals to 2x plus 1. And if I substitute 2x plus 1, then I will have y here lah, equals to 4. Okay, so x squared. What do I have as x squared? I try to move all this over. I will have y minus 1 divided by 2. Okay, do you know how I get it? Because this one, if I try to rephrase, I will have x equals to y minus 1 divided by 2, right? So the x squared, I will substitute y minus 1 divided by 2. Okay, then I have square here. Then minus 2x. So again, x is y minus 1 divided by 2. And then plus 1. Okay, so if I try to expand and simplify everything, I'll get fy, which is equals to y squared minus 3y plus 3. Okay, so this is my function f. So which means that fy is y squared minus 3y plus 3. So if let's say I'm having f apple, that means f apple equals to apple squared minus 3 apple plus 3. Okay, and because this question we want to express everything in x, therefore you can write again for fx equals to x squared minus 3x plus 3. You just change the variable from from y become x. Alright, so please take note that this and this are not the same. Alright, so I just purely want to change the variable become x only. Okay, so that I can continue to use it later. Alright, so now after you get the fx, you want to get g composite f. Okay, so how can I have g composite f x? Okay, so that means I want to substitute x squared minus 3x plus 3 into the function gx. So gx is 2, and then x squared minus 3x plus 3 plus 1. Okay, so if you try to simplify everything, 3 times 2 is a 6, right? Okay, so I'm having 6 plus 1. So I should have 2x squared minus 6x plus 7. Okay, so this is my composite function g f x. Okay, so after you solve all this, then now they want to find the value of x that satisfy this result. Okay, so fgx equals to gfx. So what is fgx? All right, so maybe if you want, you can write like this. They give you this equation, fgx equals to gfx. Okay, and then what is fgx? From the question itself, you have 4x squared minus 2x plus 1. Okay, so what is gfx? So gfx is 2x squared minus 6x plus 7. So again, this is if you reverse everything, you will get a quadratic equation. And when you try to solve it, you have x equals to 1 and also x equals to negative 3. Okay, so again, this particular question, they are testing you about the composite function together with the quadratic equation. Okay, so all these are something basic. That means maybe in secondary school, when you learn about the composite function, these are the questions that you solve. All right, so maybe I think in the next video, I will discuss with you about the domain and range for the composite function. All right,